Scatter plots and lines of fit. Investigate relationships using scatter plots. A scatter plot is a graph in which two sets of data are plotted as ordered pairs in a coordinate plane. If y increases as x increases, there is a positive correlation between x and y. If y decreases as x increases, there is a negative correlation between x and y. And if x and y are not related, there's no correlation. Let's see the example number 1. Earnings. The graph at the right shows the amount of money Carmen earned each week and the amount she deposited in her savings account that same week. Determine whether the graph shows a positive correlation, negative correlation, or no correlation. If it is a positive negative correlation, describe its meaning in the situation. So you can see here that the x, while x increases, then the y increase. For this point, in x40, you have 0. For x60, you have $5 saved. For $80, you have $10 saved. For 100, you have 15. For 120, you have 20, and so on. While x increases, the y increases. So this shows a positive correlation. The more Carmen earns, the more the saves increase. Exercise. Determine whether each graph shows a positive correlation, negative correlation, or no correlation. If there is a positive or negative correlation, describe its meaning and the situation. Let's see here. Average weekly work in hours in the United States. You have in the x-axis years since 95, and the y-axis you have hours. So if you see that from 95 to the first year, there's no increase. From 95 and 2 plus 2 and 95 plus 3 years, there's no increase. There's no increase here. There's a little decrease, but in general, there's no correlation because there's no negative correlation or positive correlation. So in this case, it's no correlation. In number 2, we have minutes and miles per hour. We see that when the minutes increases, then the miles per hour decreases. So this is a negative correlation between the minutes and miles per hour. On number 3, average U.S. hourly earnings, we see that while the years since 2003 increase, then the hourly earnings increases. So there's a positive correlation. And in number 4, I'll let you do it. Use lines of fit. In this example, the table shows the number of students per computer in Easton High School for certain school years from 96 to 2008. So you see the years here, and you see the student per computer. In 96, there were 22 students for one computer. In 98, 18 students for one computer, so on. So 2008, you have 4.9 average, almost 5 students per computer. So the exercise asked me to draw a scatter plot and determine what relationship exists between the students per computer and the year, if any. So let's see what happens here. When I draw this one, I'm going to put this one in the x-axis and this data in the y-axis as it is in this graph. The year is the x-axis, the student per computer y-axis. So I'm going to start plotting this. For year 96 here, I have 22 students. This is my first point. For year 98, I have 18 students. So this is my second point. For 2000, I'm going to have 14 students here. For 2002, I have 10 students here. For 2004, I have 6.1, and so on. Then when I have all my plot points, I'm going to draw a line here, as it requests in B, draw a line of fit for the scatter plot. Draw a line that passes close to most of the points. A line is shown. So you draw a line that closest or that passes closest to the most of the points, okay? Now write a slope-intercept form of an equation for the line of fit. For this line, we're gonna write a slope-intercept form that we know how to do it already. The form of the y-intercept form, or the slope-intercept, is gonna be y, remember, equals mx plus b. So my m, remember that my m is y2 minus y1 over x2 minus x1, where my y's are my students per computers and my x is my years. So I'm going to choose two years, and I'm going to choose 2x. So I replace these values here, and I have a slope of negative 1.7, okay? Negative 1.7. Because I choose, for example, year 2005 as being my y2, 299 as being my y1, 5.7 as being my x2, and 16 as being my x1. Replace in this formula, and I have a slope of negative 1.7. And it needs to be negative because you see that this line is to the left like this. Okay, how are we going to find b? The same thing we already know. In this formula, y mx plus b, I'm going to replace the y by my y1, for example, 1999, the x by my x1, for example, 16, and then I find b. 16 equals negative 1.7, this is then we found, times my x, 1993, plus b. I do the numbers, I find b equals 3404. Then in this equation, I'm going to replace the values I have. Y equals m, negative 1.7, times x, plus my b, that now is 3404. And this is going to be my line, the equation of this line passing through all this point, or the equation of my line of fit.